Shlaer-Mellor Relationship Formalization and Referential Attributes by Starrett at Shlaer-Mellor Days 2022. Hello, I intend to cover the pros and cons of relationship formalization. In the crowds I walk in, there are strong opinions both for and against, and I will provide a little bit of background, take a position, and present a technically compelling case in a manner which is provocative, irreverent, balanced, fun-poking, and entertaining. I hope to communicate the following points. Number one, I believe that relationship formalization is useful, but not everywhere, always, every relationship. It needs to be optional. Number two, I believe that the shape of our model data informs us and tells us when to formalize, and so we can listen to our models. And number three, I have an idea to update our notational formalism to take advantage of some speed ups here, and I covet your
Stop! He who approaches the bridge of death must answer me these questions three. Ere the other side he see.
Go ahead, Bridgekeeper. Ask your questions. I am not afraid.
What is your name?
I am Sir Cortland of Shlaer-Mellor land.
What is your quest?
I seek ideal abstraction and the Holy Grail.
What is your opinion of referential attributes?
I love them. No, I hate them. Ah!
Okay, that's something.
I think that's...
That referential attributes, I failed that so bad, sorry.
Here is the outline of our journey to support the thesis statements just established. A little bit of background and a how-to will provide context. Only the shallowest reference to underlying theory will be explored to illustrate that we must adhere to our mathematical underpinnings. A few example models will add clarity, and lastly, I will propose an idea for incorporating relationship participation into the concept of identifier. We formalize an association by copying identifier attributes from the participant class into the formalizing class. The copied attributes are called referential attributes. Rather than take you through the literature explaining this, it is easier to see it demonstrated in a model editor. First, the relationship is established, then the relationship is formalized. You can see the identifier from the dog owner being copied into the dog class with a prefix added. This is the root of Shlaer-Mellor object-oriented analysis. It is data modeling and based on relational databases and set arithmetic. Application model data can be queried just like a relational database. And union, intersection, and differences can be applied to sets of instances of related objects.
It's the math.
However, the Shlaer-Mellor method and its underlying data model did not stop there. It is not exclusively a relational database. Network database science and graph theory influenced the method from the beginning. Network databases are founded on graph theory. Classes are the vertices or nodes, and relationships are the edges in a directed graph. Data access is oriented toward relationship traversal more than instance set arithmetic. However, both are supported. The OOA of OOA supports both foreign keying as well as graph linkage. In the OOA of OOA, as used in Bridgepoint land at least, there are elements that link classes and there are elements that key classes. Elements that represent the association line between classes include relationship, simple relationship, associative, subtype, supertype, and their attributes to carry multiplicity, conditionality, role phrases, and the relationship label, which is a number. Drawing the relationship line on my class diagram populates this graph portion of the OOA of OOA. Elements that represent the relational nature of the data include identifier, identifier attribute, reference, referential attribute, and referred to identifier attribute. There are attributes to carry referential attribute prefixes. Formalizing the association populates the relational foreign key aspects of the OOA of OOA. In the model editor, when I draw a line, I populate the graph-centric portion of the OOA of OOA. When I formalize the association, I populate the relational key foreign key portion of the OOA of OOA. And by the way, the editor has a mode where it populates both at the same time. It is instructive to discuss action language. All of the modern action languages support set operations. All of the modern action languages also support relationship linkage and navigation. Action language keywords communicate the network nature of many associations. For establishing a relationship, some action languages use the keyword relate, but others use the keyword link. All action languages speak of traversing or navigating links between instances of classes. Clearly, we have a healthy and powerful mix of relational and network access nature. Let us quickly storm through the extant literature. Relationship formalization and referential attributes were introduced in Modeling the World in Data. The book demonstrated a fully relational modeling approach and yet revealed a graph nature in discussion of relationship traversal and navigation. Raystrick et al. Presumed formalization but did not dwell on it and discusses it only in the context of constraints. However, all class diagram examples in the book were shown fully formalized. In Mellor-Balser, formalized relationships were discussed again only when applying constraints. However, other examples show associations without formalization.
Honey, I'm home. What's for dinner, sweetheart?
Nothing for you, sweetheart. I understand you've been questioning the sacred merit of formalized associations, identifiers, and referential attributes.
I know of a short paper on the topic of this slide. It encourages modelers to consider context when discussing and thinking about referential attributes. Are you in the process of modeling, in the tooling, editor, interpreter, or compiler? Or are you focused on the ultimate artifact, the model itself? I say, while modeling, use every rigor to guide your thinking. In tooling, dependence upon relationship formalization is a weakness. And in the model, associations should remain formalized only where useful and left uncluttered otherwise. I have several examples. In the first example, the simple dog owner dog model, relationship formalization provides no benefit here, and in fact, simply clutters the model. The GPS watch track log has a first and last track point, and the track point is ordered by a reflexive. When we formalize these, we get clutter. I note that formalizing a reflexive ordering relation is pretty much always senseless.
Dude, that is just stupid.
This clearly is a graph-oriented data model. In fact, it represents a family tree. I would not even want to try to make this foreign key oriented. Now here is a good example of the use of referential attributes. We are using a combined referential to prevent a debut appearance from being from a different actor. This is super cool. This models the guarded gate of a community where you must present a credential to gain access to the property. In this model, we have a balance of formalized and unformalized associations. Relationships are formalized when associated in a class that will be linked based on a true foreign key. The visitor shows a born credential which exactly matches a stored credential persisted as a different class collection in a different table.
Good morning, ladies. What are you discussing this morning?
Oh, we were debating Shlaer-Mellor relationship formalization and referential attributes.
Oh, so what do you think of that?
Oh, I'm wild about them, especially when disambiguating with the combined referential.
I'm not a fan. Referentials are pretty much useless, duplicated clutter, which violate the tenet of one fact in one place.
This is the punchline illustration of this presentation. Here we have one of the most clever domains I have ever seen, and it was built by a very clever modeler with the assistance of other clever modelers with arguably more talent and experience than anyone in the industry. This is the heart of the protocol processor discussed earlier in the conference. It is a work of art. However, I shudder at the road of bones the modeler had to walk while building it. Association formalization is required in the tooling context of this particular model. And it matters not whether this requirement springs from religious adherence to methodological orthodoxy or whether it is imposed by limitations in the tool chain, the results are the same. This poor bloke had to formalize these associations, propagate the identifiers and the referentials as identifiers, including referentials with referred to prefixes. Note that to alleviate some pain, the modeler added an arbitrary identifier here and there to stem the tide of referential accumulation. The benefits gained are dubious indeed. In this case, the relationship formalization requirement is not worth any gains made. Relationship formalization has been stated. However, I have an idea that could make it easier to constrain our model data tightly in a cleaner, clearer, and easier to use way. The following idea/proposal is in addition to my presentation so far. My idea is to extend the semantics and the notation to allow for inclusion of relationship participation in the class identifier. So the combination of identifying attributes and relationship participation provides identity to class instances. Let's take this step by step with an example fragment of a Shlaer-Mellor metamodel. Here we have domain, class, operation, and parameter fully unformalized. A domain has abstract zero-to-many classes, a class provides zero-to-many operations, and each operation carries zero-to-many parameters. Each element has a name. Now, the name of a class needs to be unique, but only within a domain. To enforce this in the traditional means, we add the referential attribute of the formalized association to the identifier for class. You can see the capital I is next to both the name and the domain name referential. Likewise, we continue to propagate domain name, class name, and ultimately operation name down into the parameter. The constraint is useful, but the means of supplying it is pushing us into the realm of clutter. Here is my proposed means of maintaining true identifiers without propagating foreign keys all over the place. Here, a class is identified by its name together with its participation in relationship R1. The operation is identified by R2 plus name. A parameter is identified by its name and its participation in R3. This approach pretty much means the same thing as the referential as identifier approach, but is cleaner, clearer, easier to read, easier to edit, and much less complicated. The notation is only a first idea. It is the semantics I want to focus on and discuss with the community. The OOA of OOA may need only a single new association between identifier and relationship, and Mazel already has syntax for specifying the identifier in a list of attributes we would simply need to allow relationship references to be included in that list. Okay, let's summarize. Formalize associations judiciously. It is not an all or nothing affair. Look at the model data to inform your approach to each relationship, whether it be relational graph oriented. And in the future, we can get much of the benefit of formalization without some of the accompanying downsides. Thank you. I hope this was informative and fun.